I'm just gonna turn on the video to say hi. Okay, and then I'm gonna turn it off. This morning wasn't working. Hello everyone, nice seeing you again. Long time no seeing you. I'm glad that you're here today. We're gonna have a class. I really like this topic. Solid waste is a pretty easy, really fun, very relevant topic. So I'm hoping that you will enjoy it. So I'm gonna turn it off now because my internet is already telling me that it's unstable, and I want to make sure that you have a clear connection and you can hear the information. If you don't, please let me know right away. Okay, and then I'll see what we can do here. Okay. Let's start now. So we have the agenda on the screen. And as you can see, we're going to be just talking about solid waste. Your notes for air pollution are due this Saturday. And we have a bunch of things coming or due next week, including the project. If you have seen Blackboard already, the teams have been distributed for the presentations next week. 3 teams are presenting, or I don't remember the number of teams. The teams are listed in there. We have 7 teams. So some teams are presenting Monday, others on Wednesday. All the PowerPoints are due on Monday. And the idea is that you don't change them, and it's to make it fair for everyone. For those that are presenting on Monday, those that are presenting on Wednesday don't have extra time. They need to submit everything. And the final report for everybody too is due on Wednesday. So that gives you a little bit more time in case that you need to finalize formatting or something. Everybody has the same time. Is there any question related to it? No? Okay. The other comment is related to the grades. I don't think that we talked about this last on Monday, so I just want to make sure that it's, and if I did, let me know. Did we talk about the syllabus and you selecting a grade?
No, we did not.
Okay, so good. Thank you, Maria. So I'm gonna be sharing my screen. I'm gonna just show you the syllabus just to make sure. I do believe that the university already sent the information that you can select the system to be graded for the class. So I just wanna remind you of that we have a syllabus and it's posted on Blackboard. And in the syllabus, you can find what is the percent that each item in class has will be a part of your grade for a total of 100%. And notice, please, that on Blackboard, the grade is not weighted. You need to go and put all the quizzes together, and that will be giving you 15%. The discussion board, the assignments, class notes, practice problems, all of that is going to be the next line. And we still just have the project and the final. So right now you have midterm 1, midterm 2, and so far all the quizzes except for one that is going to happen next week, and most of the assignments also. The extra credit for the CWA presentations are going to be going into quizzes. There are going to be a few points for quizzes. So if you submitted that, it's going to go there. If you haven't submitted, please submit ASAP. And there's going to be another opportunity to attend another presentation that is going to also give you some points for the quizzes. That is going to be next Tuesday at 4 o'clock, and I'm going to be posting the Zoom link for you if you want to attend. It's a presentation of a master's student that is defending on Tuesday. And I think the topic is very interesting and is relevant to the class. It's related to flushable products that goes into the sewage system. So it's solid waste, wastewater, environmental engineering, and actual practical issues on the field. So that's the last type of extra credit that we're going to have. And again, it's extra credit. So if you cannot, you have another class or project, I'm sorry, it's happening at 4 o'clock on Tuesday next week. Is there any question about this?
So any extra credit, we just turn it in by the last day of class, or?
The extra credit, if you went to the CWA, submit it before Friday next week, please.
Okay.
Because I'm going to start processing everything. I usually do it the week of the last week of class if I can, and because I really like to keep everybody's grade as early as possible. That's my goal, right? So please, all the extra credit due is are due by Friday next week. Okay? At noon, please. All right, good question. Okay. So what we are going to do now is showing you some videos related to solid waste. I do believe that a very good way to introduce you to this is going to be showing you some videos that are. I'm going to share my sound. If you don't hear, let me know. Hopefully it's not too loud. Well, we can fix it anyways. So the solid waste problem or topic is very interesting, and it's actually very close to our daily lives. And I really like this topic. So I'm going to play it. Let me know you can hear well. Oh no, the internet. Can you hear?
Yes.
Most people think in Harford County they can only recycle paper, bottles, and cans. Unfortunately, many people do not realize that they can recycle textiles, clothing. And we've been doing that here in Harford County for approximately 15 years. We typically take in approximately 10 to 12 tons of textiles per year. Huge amount of material being diverted from the landfill.
Donate, recycle, don't throw away is our motto. And it's very important because what we're trying to do is educate the public about textile recycling. Most people don't know that most of the items in their home that are clothing or any kind of textile can be recycled. And our goal is to educate them about that so that these items are not thrown away.
I think textile recycling is important because it basically gives you the opportunity to put back into use materials that otherwise are slated for the landfill.
SMART is an association, nonprofit trade association, comprised of wiping material companies, used clothing recycling companies, as well as fiber conversion companies. Our mission is to encourage the diversion of textile or clothing waste from landfills, and our members do help to do that by recycling textiles and used clothing.
We take practically any type of textile.
Rugs, stuffed toys, one shoe or flip-flop, in addition to clothing, linens, sheets, carpeting, belts, purses, any kind of textile or clothing can be recycled.
After the customers drop the textiles off, they're sorted and graded. The material textiles that can be reused are reused. They're palletized and shipped to third world countries. The material that can't be reused is sorted out and turned into shop racks. It doesn't make any difference what condition they're in. We'll accept them.
Our members, SMART members, have been able to divert 2.5 billion pounds of these textiles from the waste stream. But to put it in perspective, we could be doing so much more. Currently, that's only 15% of the total textiles that could be recycled in this country. And we can really make a difference if we encourage people to recycle their textiles.
By recycling this material, it keeps it out of the landfill and puts it in the hands of someone who can reuse it.
Okay, so that is one of the videos. I don't know if you have ever wondered if there is any sense or makes sense to do recycling or donating your things that you don't wear, especially clothing in this case. And this video can tell you that there is a lot of money and jobs available just by doing this. I'm going to play another video. It's related to recycling. This is just a slightly different type of material.
I think people think of recycling, and it's people bundling their newspaper and Boy Scouts moving things, and people are kind of fascinated, and I guess they're surprised at sort of the large industrial and highly mechanized nature of the process. My name is Thomas Outerbridge, and I'm the general manager for Sims Municipal Recycling. Well, so we're in the business of receiving, processing, and marketing mixed recyclables that are collected by municipalities from their residents. We service the 5 boroughs of the city. It includes all rigid plastics, so everything from a laundry hamper to a toy to a plastic bottle, all glass and all metal products, from tin cans to bed frames. We have to basically take this mix and sort it to a fairly extensive degree to turn it into a commodity. If you didn't know what you were looking at, you'd think it's just garbage. The materials accumulate on the tipping floor, right? It's dumped there by sanitation, or we unload our barges there. We then have a front-end loader, big front-end loader that feeds a conveyor, and that will transport the material to the Liberator. The Liberator is a slow-speed shredder. Call it the Liberator because the idea is really not to cut things up, but to really open bags and disentangle stuff. People who live in high-rise buildings accumulate these bags in the basement. Some people think plastic bags, just because they're plastic, they should be recycled, so they stuff bags full of bags and then stick those in the bags. And so the Liberator rips everything apart so that when we introduce it to the sorting equipment can do its job. Disc screen are these discs, and they spin and they throw the material forwards, and there's gaps between those discs. So anything that's less than 2.5 inches goes through the disc screen, and that is really targeting glass. So it's removing 95% of our glass. We send that to our glass plant in Jersey, where then it goes through a whole nother set of sorting steps, and then crush the remaining colored glass into an aggregate. After removing the glass, the material passes underneath large drum magnets, which are big drums that turn and pick up all the ferrous metals. Those ferrous metals then go to another trommel screen where we separate the smaller ferrous metals like tin cans from the bigger metal furniture and things we get. Then after we've removed the glass and the ferrous metal, we introduce everything that's left now on the belt to ballistic separators. 2-dimensional material will lie flat on these paddles, walk up a incline, whereas 3-dimensional material will bounce back. So now our 3-dimensional material goes into a whole sequence of optical sorters. Different materials have a different spectrum in near-infrared light, so we can distinguish plastics by resin type. So it is looking for anything on that conveyor belt that is PET plastic. It's telling the air jets, here comes a PET water bottle. We use air effectively to blow it off of the conveyor belt and separate it from the balance of the material. Whatever is not ejected as PET then travels on to the next optical sorter. They go very, very fast. They go much faster than a human being could possibly pick. They're looking at 7 tons of material an hour. Each step along the way, you're going after one more item until you left with ideally nothing, but of course odds and ends that shouldn't be in there that end up as residue at the end of the process. Most products are put into balers that make bales.
Okay, so I'm going to stop this here. I think that we have watched enough. I just wanted to show you how intense the solid waste industry can be, and this is just showing you the recycling part. We have another video for the landfill, showing how the landfill looks like, but I will show that to you later today or maybe next week if we have enough time. So that is a way to introduce the solid waste topic. I am going to show you something else. Some of the slides. I do have the slides on Blackboard, so I'm not going to be covering everything. I'm just going to be pointing out a few things because you're going to be doing your reading notes. But let's go on with this in here. Can you see my screen?
Yes, we can.
Okay, hold on. What happened here? Thank you so much for letting me know. Swap. Okay, now it's working. So we're going to be talking about solid waste, how we are managing it, and some ideas for resource recovery. We don't have enough time for in-depth cover of these topics, but I can tell you that it's very fun, and we have a lot of need of engineers in this area, especially here in LA because we have a large amount of population. We're going to be briefly talking about fundamentals. We're going to discuss some of the issues that you have seen, some of, not the issues, the way that engineers have and people very creatively have dealt with the solid waste to make sure that they save the environment, they protect the environment, they protect human health, and then we make money and we get jobs out of them. And that what you saw is one of the things that we call the strategies for reduction of volume of the solid waste. And so it doesn't end up in the landfill. And then when we do design of landfills, the landfills are minimized to the maximum. And mostly all the idea is that mostly all the things that are going into the land waste could be maybe degraded or just buried permanently if they cannot degrade. It takes a lot of time to degrade. I have a slide with the videos that I just watched you. So all of this is found on Blackboard if you need to. So I'm going to be briefly talking about this societal perspective. We all produced solid waste. All of us, each of us, every day. I have no idea how you have spent the pandemic time where you've been mostly at home. I have been reflecting a lot. My solid waste has increased, and with time, I've been trying to what can I do to minimize it. So I'm just gonna be sharing my perspective, and also you could share your perspective if you want to. But this is related to how we see it, how we are experiencing the solid waste, the generation of solid waste. And this is not very complicated. We know that we need things and they could be coming grabbed or with some, they can produce some waste and we just need to get rid of it, right? And we don't like it. We don't want our trash in the kitchen because it smells bad or the bathroom everywhere. So we don't like it. We use it and we send it away. So we get rid of a lot of things and our society has been developed based on using, I don't need it, and then discarding it. So this, the class, I have tried to make it in a way that I can prime a thought of, in view of, do I really need everything that I'm getting, or can I just reuse some of the things? Or right now in the society has developed a way of thinking of, it's actually very trendy among young people, going to the thrifting, right? So think about those possibilities for improvement of the environment. So again, I'm not gonna go in little details. You have all of these slides, but I would just wanna bring up a few points that are important. So the definition of econosphere, it's a term that is just defined or describing a society where things have a monetary value, right? They're material goods and you want them or we want them, and that's what we they have value for us when we have them, and when we don't need them we can sell them for a price. So it's something that is important to keep in mind, by the way. That is important to keep in mind, and we can think about how we can improve the environment in that way. So unfortunately the society has developed, in the society members, the thought of the need for new things, fashion, style, cell phones, trendy stuff, and all of that. From the point of view of an engineer, it's going to become solid waste at a given point. So I want you to take the side as an engineer and think about it, what the solid waste could represent for you. You are going to be serving the society, if you're working on the solid waste industry, by collecting and processing the solid waste and making sure that the people or the population is healthy by removing the solid waste from where they are, right? And then finding a good way so it is not a sore for the city, or maybe an area where could cause illness. So what is going to be the perspective of the engineer? I have a question for you. I don't know if you have ever thought. Do you know how much waste do you produce per day? Any idea?
Isn't the average amount about like 4 pounds or something like that?
Okay, so someone is saying 4 pounds. On the chat, someone says, I don't know. Others that I haven't ever thought about it. Well, I think that you are very close, Samuel. Generally, an estimate, some people will produce more, some people will produce less, and also it depends on where you live and the culture that you are part of it. In US, we are about 2 kilograms per person per day. And it can be classified, depends on where it is collected. We're going to be talking about mostly domestic waste in the class briefly today. And it can be classified in different types: organic, inorganic, combustible, hazard, and hazardous. And based on that is the way that is going to be processed too. The density varies based on what it is. Probably the kitchen waste, food waste, is going to be way denser compared to something on the restroom. I'm assuming that it is only tissues or toilet paper, maybe wrappers from toilet paper rolls, etc. And the composition, I'm not going to go into all the details because you have it in here, and it's going to be part of the reading notes and the reading materials, but it could be many different kinds, and the proportions are going to be different. All these photos are from your textbook, or tables are going to be from your textbook. But I can tell you the classification mainly is organics, inorganics, and hazardous waste. Okay? Within the organics, you can have jar trimmings, or wood, or food, plastics, etc. The proportions depend on where the waste is coming from. MWS is going to be referring to municipal solid waste, or the domestic waste from homes. So waste is not only a source, and waste can be recycled, but there is another way to process the waste, which is going to be by incineration. So as you saw, by recycling, which is one of the ways to manage the waste, we can have a generation of maybe a source or a resource for someone else, or maybe just a way to get jobs and some money. But also by incinerating some of the waste, we can get some energy. And this table, I'm not going to read it, but this table tells you the classification from the Incinerator Institute of America of the waste and the energy, or the megajoules, that could be obtained by the incineration of some of the materials. There is a value in terms of energy on the materials too. So this is a big industry. And again, keep in mind, how are the ways to process this solid waste? We talk about recycling when we watch the videos, and now I'm putting in here the incineration. So this is another way. And we're going to talk about a third one. So the waste can be incinerated. Also, the waste, the solid waste, we're talking about domestic waste, can be hazardous waste. All the, if you have paints or cleaners or oils, or the car batteries, or the batteries that we use for different parts of things like the cell phone or the remote in our homes, all of those are going to contain hazardous chemicals that should not be going into the dumpster. So we need to make sure that we know how to dispose of those. That is also solid waste. If you haven't done that, you haven't done separation, and if you're still tossing everything in the trash can, it is a time to think about how can you help the county, and how can you help the community separating the trash. If you don't have the space, there gotta be a creative way that you can do this, or maybe with the family members that you're living with. So there's a lot of concerns related to the solid waste. It could be a fire or a hazardous waste. They could produce some odor vectors. So you know, a vector, the word vector means mosquitoes. And that's the formal or technical word in environmental engineering. On the field, in infrastructure, a vector development is the development of mosquitoes in a given area. So it's very important that you remember that one. Also could look bad or maybe contaminate surface or groundwater, or there is pathogens around. So those are the issues, or can bring pathogens into the environment. So those are the main issues with solid waste. How do we manage the waste? Well, ideally we want to reduce the waste. How we're going to be reducing the waste? We're going to be doing incineration. So we need to identify or separate what of the things have value for energy extraction. We are going to be recycling, and the third one is going to be composting. So that can start at home, or it will start, if we don't do it, the city, whoever is collecting your waste, has to do it. And then you saw in the video that someone was saying, the person was saying, well, if they just put everything in there, we have very fancy, well, for me, sophisticated equipment, because whoever designed that equipment need to know the properties of the material that they're separating. There is a lot of science and chemistry and physics behind that to be able to design a system that rotating or with air or sensors can actually separate or just shoot some air to, based on the density, they know how much the jet of air has to be sprayed on the plastic. So only that one that they want to separate, it's blown away and removed from the stream, right? So there is a lot of science. It's very easy and straightforward, but in real life, if you want to be in that area, you are going to be encountering limitations and people not doing what they need to do, and how you're going to be solving this problem. But you're going to be the engineer that needs to bring the creativity and the scientific knowledge that you have in physics, chemistry, and math to be able to develop a new item in industry. There's a lot of money behind that, the technology development. So remember, we need to manage the waste to ensure that we can protect the environment. This science or this practice on the field is called integrated solid waste management. And if you are working in the future in this area, you will see that it's a very complicated thing to do, because you need to work with people. You cannot control what people do, but the only thing that you can do is collect the waste and then see what is going to be done with it. So you might be the engineer managing the solid collection, the solid waste collection, or the solid waste distribution or processing or separation, depends on where you're working. I'm not going to be going and reading these slides or diagrams, because you are going to have the time to go and sit down. We have the generation, we have the handling and processing, collection, separation, and then the disposal. Whatever cannot be recycled, composted, or incinerated is going to go into the landfill. Okay? So the resource recovery is related to those three things that we just talked about it. But the last one that I forgot to mention was reducing. So we could sell, and something that is no longer useful for me can be useful for someone else, right? And I do believe that in our society, we still need to work a little bit with that, because some of us have a hard time thinking about using things that others have used, especially now with the pandemic. But maybe some things can be clean and decontaminated, right, and then you can use them too. So I'm going to skip all of these. I just want to mention again, remember the type of waste, the amount of waste, the practices on how to reduce the solid waste are going to be depending on if you are in a rural community or an urban community, depending on the state that you are, depending on the family that you grew up with, and depending on the country too. It's going to be very related to the geographical location where you are. And also to the characteristics of the solid waste collection system, because some of the cities provide trash cans for recycling, for separating of different things, and some of them don't. There's a bunch of information. All of that is on the PowerPoint and tells you current information related to recycling and composting. I'm not gonna go into it, but it's very important that you get fund recycling. Go to your local service and see how you can discard different things, a paint or battery if you're changing your battery in your car or things like that. All right. So I think that with this, we are done with talking about the solid waste. Can someone repeat the 3 ways that we can minimize the solid waste that goes to the landfill? Well, actually, I mentioned 4, right?
Compost.
Compost,
Recycling.
recycling, remember the fires in California? Energy recovery, incineration, and then reuse. Recycling doesn't mean reuse. Recycling could be like the metals, aluminum being recycled and then later processed for something else. Reuse is direct use of the good. Maybe a cup of plastic cup that we don't want and I sell to someone else and someone else is gonna use it. Is it clear the difference between reuse and recycle? Yes? Okay, I'm hoping it is clear.
Wait, what's the difference again?
What is the difference? Recycling means you're separating, right? We're separating plastic from cardboard from aluminum. So the material can be maybe clean and processed, and then I don't know what's going to happen with it. Maybe they do something with it, or maybe they just put it away. Reuse means the good is not going to be destroyed or processed. It's going to be used as is by someone else. Like clothing being used by someone else, a chair that you sell and someone else is going to use it or reuse it. Does that help?
Yes.
Okie dokie. Okay, so now we're gonna do problem number 1. I'm gonna go to the iPad. And we are going to talk about the solid waste that is produced in 2 different countries. So it's like if you like football, this is like a football match. Who is gonna win? Well, we'll see who wins in problem number 1. So in problem number 1, we have a town of 20,000 people that is going to be generated in Germany, that is going to be generating 0.95 kilograms per capita per day of municipal solid waste. A town of the same size in United States generates 1.9 kilograms per capita per day of municipal solid waste. Oh yeah, we're winning, isn't it? US is producing more. Is that good?
Definitely not.
Definitely not. Yes, I know. Anyways, is the average, right? How much municipal solid waste is generated in each town? So we're going to be doing a few different things in here. Let me just keep the chat in here open just to make sure that I can see answers if they come up. All right, so let's do the part 1. For part A, let's start with Germany. So now the challenge with the solid waste is there's no formulas. Everything is going to be just matter of converting units. So you need to be looking at units. The units has to be consistent, and so the solid waste we need to calculate the generation, and usually it's going to be expressed. In this case, it's mass per day, but in this case we have kilograms per day. So it's mass per time. I'm sorry. So it's very straightforward. We know that we have a population of 20,000. And I know that it's produced 0.95 kilograms per capita. What does the word capita mean?
Per person.
per person. So people and capita go away. And then I'm going to end up with kilogram per day. So that will give me what I'm looking for, right? And what do we get?
19.
Yes, thank you, someone. The chat was quick. 19,000, and I hear some 19,000, so everybody go the same thing. Straightforward. And if we do the same with US, I'm gonna put a pin there. 9 kilograms capita day. And what do we get? Oh, it's already on the chat. 38,000. Can someone confirm? Who's the winner here? US or Germany? Nobody wants to say, right?
Germany.
Yeah, Germany. Don't worry, it's not soccer. Yes, in soccer, I don't know. By the way, I have to disclose this. I am an American citizen, but I didn't grow up here, so I still root for my country when it's in soccer-related games, okay? So, anyways, it's not a good team. I don't even want to tell you where I am from. They played really bad, but what can we do? Alrighty, so we have part A done, straightforward. Now, we need to calculate the number of trucks that we'll need to that we will need to collect the waste twice a week. So now, think about this. You could be the one doing this job. You could be the one that's saying, okay, how much waste do we produce? Now, how many trucks do I need to have ready? And that's going to be depending on how often the waste has to be collected, right? And then we need to take into account the size of the truck. And here says the truck each have a capacity of 4.5 tons, metric tons, and operates 5 days a week. We need to assume that the truck has an average of 2 loads per day at a 75% capacity. So they don't overfill the truck because some of the material when it's put into there kind of gets bigger, expands a little bit, right? And then the space is going to be taken. Okay, so let's do part B. Part B also is straightforward. We just need to think about all the givens. First of all, let's calculate how much we are producing, how much waste is produced per day, per week. Because if you think about it, the trash has to be produced every day. We don't say, oh no, I'm going to stop producing trash because it's Saturday and Sunday, right? Actually, probably are the days that we produce more trash, or at least before the pandemic. So let's go to Germany. In Germany, if we have 19,000 kilograms per day of trash, and we have 7 days a week that we have this being produced, we know that we have, someone is saying that Germany will win in soccer or solid waste. Yeah, they're really good. They're really good playing. So someone gave me the number. Is it correct? 130,000 kilograms per week?
Professor?
Yes.
Does the question say like the amount of days?
The question says how many?
It says 5 days per week.
It says that the truck operates 5 days per week.
So would we have to calculate the amount of waste for 5 days because that's what's going to be picked up, or?
So yes. So think about this. I can put a note in here. You think first we are talking about. Let me put it in green. The waste produced per week. So now think about the side of where the waste is produced, the household. We do not stop producing waste, even if it is Saturday or Sunday, isn't it? Even
Right.
if you are at home and you know that the waste doesn't come until Tuesday, you still start accumulating waste. Yes? And when the
Yes.
truck comes, the truck needs to know. I mean, they have two pickups, but they need to estimate. They estimate how much waste is going to be produced per day, so they can estimate per week, and they can know how many trucks to bring twice a week. Only 5 days, right? So that's. I'm sorry, I'm missing a zero. Thank you for someone told me in the chat. So this 133K is the amount of waste produced at home. Put it here, at home. This is not what is, the truck is gonna take it in 5 days. We are producing it in 7 days, okay?
Thank you.
Produced in 7 days, all right. See, that's very important that you see. That's where the solid waste topic is very confusing because you need to separate when we produce it from who's managing, and they need to schedule, and everything has to be organized to make sure that you come and collect. All right, so if we do the same for US, let's just calculate the waste. It's going to be 38,000 kilograms per day times 7, and we get 266,000. Someone is really quick on the chat. Thank you. And can we check the number?
I got the same thing.
Okie dokie. So now we have the amount of waste that is produced at home. Now let's look into the engineering side that is going to be coordinating too. Let's remember we have 2 loads per day for each of the trucks. It's going to be running at 75% capacity. All of this is coming from the blue that I highlighted out here, all right, up there. 75% capacity, 5 days a week, and it's going to have a 4.5 tons per truck, right? For every truck. Alrighty. So let's do this calculation now. I'm going to start in a different page just to make sure that we keep the whole thing together. This is part B, still part B. So I have, this says that if we have 2 loads a day for the truck, and it's running at 0.7 or 75% capacity, and also we have a 0.5 tons per truck, right? Per truckload. And how many tons in a kilograms in a ton?
1,000.
1,000. All right. And if we do all this, what do you get?
$34,000 kilograms a week.
94,000?
Or sorry, wait.
2
2
tons.
loads a day. Do we have to do 5 days a week?
Oh, we're gonna do that soon. Hold on.
Okay.
Oh, you already divided the. No.
I
Let's.
did it all. I did kilograms per week.
No, let's do it in a different step. Let's do it in a different step.
I got 6,750.
Okay, 6,750. We're gonna have kilograms per day, right? For the truck. So we're gonna have this tied to the truck. Alrighty. Now, how much waste do we have? This is this truck. Assume that is the same in Germany and US. Okay, so the truck is the same type of truck. So now in Germany, we are producing 133K kilograms per week. And then we know that we are going to have 5 days a week collection, right? So what am I doing is dividing the amount of waste into 5 days only of collection. And that will be what? Thank you for confirming this on the chat. How many kilograms per day do you get for the collection?
26,600.
26,000. All right, 26,600. Someone confirm? Okay, it's already on the chat. Confirm. So this is collected, right, per week. Now we can. How can we calculate the trucks? The number of trucks? What am I looking for? The number of trucks, right? Do you see this number up here?
You would divide the 26,000 into the 6,000.
Exactly. We're gonna be dividing the 26,000 by the 6,750. So in Germany, the number of trucks will be equal to, use the black, 26,600 kilograms per day by 6,750 kilogram per day per truck, and then this goes away and we end up with the number of trucks. And how many trucks did you get in there?
Four.
It's 4 trucks. Did you get a 4 or did you get a small number, smaller than 4?
A little less than 4.
I got 3.94, so I guess round.
Okay, so it's 3.94, but we always need to make it larger, right? What if you get a 3.1 or 3.2? Would you round it down?
No,
Round up.
Round it up, why?
because maybe you probably won't be able to pick up all the trash. So you have to account for any extra.
Exactly. So that makes sense, right? Right? Alrighty. So rounding up or down is relative to what you are doing. This is very practical. This is very important. So can we do the same thing for US? For US, we had not in here, we had 266,000 kilogram per week, and then we have 5 days per week. So it's a repeated calculation, identical. And then my second calculation is going to be whatever I get in there divided by the same number, 6,750 kilograms per day per truck. Okay, anyone has the number that we're looking for here?
I got 53,200.
Okay, 52,200. And can someone confirm? And now the chat is empty. Yes? Okay, so we have someone else confirm it. Thank you. And what is the number of trucks?
8.
8 trucks. So it makes sense. It was kind of Germany was producing half of US, somewhere in the neighborhood, so it makes sense 8. So this is what I'm telling you. I really like this topic, but I have to caution some of you. If you get lost because of the unit conversion, there is no question, so you just need to think about what is it that you need to go to, and then let the units take you there. So that could be the challenge for some of us. Okay, for some of you, it's gonna be very easy because you're very you have a lot of practice, or you're really good working with the units. Anyways, so let's see. We still need to do part C. So this is part B. Any question about part B? No. Okay. Part C is an easy part. I'm gonna change pages. Part C. Well, let's read part C first before changing. In each of the town, if each of the town recycles waste in percentages. Oh, I'm gonna give you the percentages. This is figure 13.4 in your textbook, but the percentage for, let me put it in red, for Germany is going to be 16% of recycling. and US is going to be doing a 23% recycling. Okay, so this is given. This is part of the given. So if they recycle that amount of the municipal solid waste, and the density of the waste is 280 kilograms per cubic meter, what is the volume of the municipal solid waste? So we are about to do design. This volume will be the volume that we will need on the solid waste, and we're gonna be in the landfill, and we're gonna be designing the landfill based on the volume that the people produces. So that will be leading us to design the solid waste, the landfill. All right. So we know that the recycle is 16 in Germany and 23 in US. This is part C, and we need to let's put an equation in here. It's not truly an equation, it's just a relationship that I'd like to put down just to remember. The total municipal solid waste is going to be equals to the municipal solid waste that is discarded. And what is that? Goes to the landfill. There is no way to recover anything, plus the municipal solid waste that is recycled. And then if there was composting, you could add composting in here, it was incineration too, but let's just assume that it's only discarded and recycled. And we are looking for this one, correct? Whatever is going to the landfill. And we know that for Germany, the recycle is 30%, for US, the recycle is 26%. So it's gonna be very easy to do this. So let's talk about Germany. Germany has a 19,000, and correct me, my numbers are wrong, 19,000 kilograms per day, right? But 13% of it is going to be recycled. So minus, no, 16%, I'm sorry. Minus 16 times 19,000. And what did you get?
$16,000.
16,000?
16,000.
All right. And this is what? What is this number? Is the one that we're looking for?
Kilograms a day of municipal solid waste.
Okay, so it's a municipal solid waste that is discarded. All right. Okay, have you done the one for US? We know that it's at 23%. And we're gonna be subtracting what is recycled, right?
29,000.
29,000. Now it's important not to round down, because then you're gonna be assuming that you have less waste, and you might end up without the space in the solid waste in the landfill. All right. So here, don't be tempted to round up or down. I will just use the numbers, the exact the numbers that you get in your calculations. All right. So we know that the waste has a density of 280 kilograms per cubic meter. How do I determine the volume of the municipal solid waste discard?
Mass over density.
Mass over density, right? Okay, so our volume of municipal waste is going to be equals to, or of the amount of discard that we have per day. I'm gonna put the units in here, divided by the density. kilograms per cubic meter. Okay, again, this is not an equation for solid waste. This is just from the definition of mass over density, like I think that was Matthew saying or participating here. So now we can calculate for Germany. The solid waste is going to be equals to 16,000 kilograms per day divided by the density, 280 kilograms per cubic meter. That in this case, we're gonna use the same one. However, in real life, every country probably is gonna have a different density. And I will guess that Germany has a, well, I don't know if it's larger or not. I was about to say smaller, but who knows? All right, we have 20. Okay. Can someone give me the numbers? Okay, we have for Germany 57.4 cubic meters per day. Everybody okay with this number? And then they gave me for US is 104.5. Oops. Let me. And the units are cubic meters per day. Yes, everybody happy with the numbers?
Professor, it's 280 in Germany, right? Not 228.
280, yes. Yeah, I think the number that was given on the chat is, the answer is correct. The 57 doesn't change. 57.14.
Where that density value came from? For
Huh?
Germany? Where did the 280 come from? Again.
290 is the density given on the statement. The density of the waste. Okay, so someone else said on the chat, yes, okay with the numbers. I'm hoping that everybody else is okay with the numbers too. And this is it. Now we have the volume. We could just go and design our landfill with these numbers. In this city, this town in Germany, they will need 57, let's say 58, 57.5 cubic meters per day for the waste. And in US, we need 104.5 cubic meters per day times 265 times I don't know how many years the design of the landfill. We're gonna do a problem like that. Hopefully we have time. If not, well, we'll see.
Why don't we
Questions about
start
this
with
problem?
volume? Why do we have to convert it to volume at the end? Why can't we just take the volume of the truck and then calculate it that way?
You are bringing a very good question. Can you see that there is a lot of different ways to solve the problem?
Yeah.
There is different ways. I have 3 different ways on my notes, and I always pick a way that kind of breaks down a lot of different things to show different things, but there is not a unique way. As long as the volume is the volume of the truck or the volume of the waste, and the time is the collection time or the waste is produced on whatever days, as long as those different parameters are taken into account in a correct way, any way to solve the problem should be giving you the same answer, similar answer, and it should be correct. Okay? That is a very good question. So luckily or unluckily for some of us, they like to have a step-by-step way to solve problems. Solid waste is a little bit more open in that sense. Any other question about this problem? No?
How much? What's the lifetime of a landfill? How many days does it have to hold?
Oh, it really depends on the designer, but usually it's on the order of hundreds of years, because you're gonna be burying the waste in there, and it's gonna be on the order of hundreds of years. You really need to go into your city.
I mean, how many days until they fill it up? It just depends on the space they have available.
Okay, I see what you're saying. No, ideally you want to have at least 15 years of space to be able to put your waste in there. But also I will say this with caution. The 16 years is kind of a good parameter, but it really depends on where you are, and the longer that you can have it, the better. And usually the space is going to be constrained by something geographically. Maybe there is a reason development, it's a private property. I don't know. But I think that 16 years, 16, 20 years of actively putting the waste in there before it's capped, it's a good number, conservative number. That is a very good question. I'm going to go to problem number 2. Oh, sorry, it's not here. It's in the next handout, here. Problem number 2 is a very fun problem. We need to come up with the route of the truck. Now, you may have software to actually design the route of the truck, right? But when you check the route, you need to know what's going on and what's good and what's bad, and then correct whatever the software didn't. The answer that the software gave you is not correct. So we're going to do a very quick exercise here. The following neighborhood has a one-way street running east to west. So the one in the center is the one-way street. And in general, the truck can only pick up from one side of the street at a time. For part A, we need to assume pickups can be made from both sides of the street at the same time. So what we're going to be doing, if the truck is here at the center, if the truck is at the center, they can pick up the trash from both ways as it goes in the center. And then on the one-way street, and we need to have a route in which no house is passed twice, and that is called deadheading. So since this is the first exercise, I'm going to do it. With the second one, you're going to do it. So let me just erase this, and we know that in the center, we're going to be picking from both sides at the same time, but we don't want to be driving twice in front of every street in a given house twice, because that is waste of time, right? The truck is driving to the house, but it's not picking and going. We should avoid that. So for the first proposal that I have, I'm gonna go, the truck goes in the center, and then it's gonna be changing directions towards this street. Now remember, the one in the center is the only one that is a single way or one way. So these streets on the sides, right here, they're gonna be two-way streets. So the truck is going with the red all the way to the north, and it's gonna come to the right, in this corner, come down, and then cross to the one-way street, and it's gonna be doing the same thing. And as it goes from the south to the north, since it's a two-way street, it's collecting from one of the sides in each time that passes in there. So we are avoiding the deadheading in there. Okay? Is everybody following me? It goes back and goes out. So that will be the route.
So why is it being drawn like that? I'm not really sure what I'm understanding.
What do you mean, the direction that it takes?
Yeah.
Because when I'm doing in this direction, as the blue goes, it's picking from both sides, right? The one-way street is picking from both sides.
Yeah.
And then as it goes down, this is a two-way street. So it's only picking from the side that is now full with blue, right? That's the side that has collection. And then this side is gonna have collection, and then all these sides are having collection too. All right? And then going in here, and then it's gonna go down, and it's gonna go around the block again, and only doing collection from one of the sides. Does that make sense? So we are avoiding the deadheading. Deadheading means driving twice to the same place without collecting. I mean, you collect once and then the second time that you pass by, you're not collecting. All right? So by doing this fashion, it's avoiding the deadheading. Let's look at the second one. The second figure is going to be for you to try to attempt. We have 5 minutes. I think that we have enough time. If trash can only be collected from one of the sides, from one side on the one-way street at a time, it's a busy street. Have you ever been in LA downtown, in those streets that have like 6 lines or something like that? Or maybe not 6, 4. The truck could not pick from both sides because it's so busy that there is no way to move from one place to another, right? From one side to another. So it will need to drive twice in that one-way street. First on the north, or first on the south, or first on the north, or second on the north, depending on what you want to do it. So we're going to be picking one side of the one-way street at a time, and we need to modify the route depending, so we minimize the deadheading and turns. All right. Can you attempt to do this in your handout? We have 8 minutes. I think that is enough time to attempt something and then to share. Yeah, some of you on the chat saying, yeah, I can try. Yeah, let's try it. Should I give you 3 minutes in breakout rooms and they'll bring you in so you can talk about it? Let's do that. Let's do that. It is 3:38. I'm going to be giving you 3 minutes and then I'm going to be calling you back in. All right?
Hey guys.
Hello.
Hey.
I'm so sad that she have class today. Like, I'm really sad.
I know, right?
All the other classes are canceled except for hers, and I'm just like, are you kidding me?
I did have another class today, but it was pretty empty.
Oh.
Any ideas on how to do this?
No.
I know.
I was gonna go the other way, like, you know how we just draw what she did, right? But just right?
Yeah. I mean, it's. I think this is gonna take, like, a lot of trial and error.
Yeah. And she's like 3 minutes, and I'm like,
Yeah, I'm pretty clueless too.
This is gonna be fun if we have to do it on a test. Gonna take a long time.
Yeah, I still have to do the air pollution problems too. They're due Monday.
Yeah. You should be able to share your work.
how?
I don't know how.
I literally draw it on my freaking notebook. Oh no.
Ay, ay.
I feel like we go. So you know how she goes and then she went down. We can go up
Yeah, that's what I did.
and then just kind of
It's
go with
kind
that.
of working. We'll see where.
Yeah, I feel like that's how we do it. Just move like instead of going down, you go up.
Yeah.
All right, we're gonna say that. If she called one of us, we'll say that.
Okay.
And we're leaving.
Oh yeah. Well, I drew it, but even if we go up, it still leaves. We still have to come back. But I guess that's fine if we.
I mean, we could just tell her that's what we came up with, but it didn't work out.
Yeah.
She can't expect us to get it right
Yeah.
in 3 minutes. That's crazy.
Close. Now everybody's back. Who wants to share? Anybody wants to share the idea?
I don't have a camera, but I could explain like how we went about it.
You cannot share the screen?
No, my camera's broke. I have to get a new one.
Nobody's not the camera, it's the screen.
Oh no, I wrote it down.
Oh, you did on paper.
Yeah.
Well, anybody else? Or should we have not going to the trouble of explaining?
I can try showing with my camera, but it's on an iPad and there might be glare.
Well, let's try it. Let's try and see if it's not.
Oh, wait, I don't know if my camera works. Let me see. Sorry.
I can try mine. I'll show mine.
Alrighty, Matthew.
So my process was I would go this way, and then up, and then over, and then back, and then I would go that way. So I'd have to go twice, and then I repeat that process.
Okay.
Oh no.
You can annotate with the Zoom tools on the top, the options, and you can annotate it there, and it's easily.
How about that?
Yeah.
Okay, so I would go forward, and then I would go down, and then I would go back, and through the middle, and then I would repeat that process. So I go like this. And then
All
like
right.
that. So there, I guess you would deadhead once through the middle 3 times.
Okay.
Once here, once here, and once here.
Fantastic. That works really well, actually. It's the first time that I see that one. Any other proposal?
I have a question.
Yes.
When you say only from one side, do you mean like only like the even numbered houses basically? Like that's why some houses have different trash collection days?
I think that the trash collection days might be really depending on how much you're paying. Like the regular service could include once or twice a week based on the route, right?
Oh, because where I live, like the people that live on my side of the street, they get their trash picked up on one day, but on the opposite side, it's on another day.
Yes. Okay. Thank you, Tanner. Thank you for bringing that up. So based on that, maybe in the example that we have on the screen, let me see if I can share my iPad. Might not be fast enough. That's more detail. the city might decide we're gonna be only driving through here on Monday and we're gonna be driving through here on Wednesday, right? That's what you're looking at, and that's the route that they design.
But that's not what this question was asking.
No, this question was asking the collection for the one-way street has to be done in 2 passes because it's a very busy street.
Oh,
So
okay. I
just
thought it was
assume-
what I was saying, so never mind.
Yes. No, but thank you for bringing that up. I think that is a very important comment to make, very practical, and brings the complication of solid waste. So everyone, this is it. It's 3:46. We went over time. I told you, solid waste is very, very exciting. I will see you on Monday, ready to see your project. In the morning, I will have office hours. If you have some questions, send me emails if there is any question too. And if I don't see you, I hope that you enjoy the break. Take a little day or maybe an evening to rest and get some energy back.